writing examples. That way we are good. In the next class we will see exception handling, how to do exception handling in the Apex. Then we discuss about set list map, right? So those we need to discuss, then followed by the SOQL and SOSLs and all. That's fine. So now let's go ahead and see the when to use interfaces, when to use abstract classes, all these things. Because in most of the cases we hear about those terms. So question is, explain class, interface and abstract classes. So the first thing is that the first thing what we need to understand is that when to use class, because till yesterday we were writing classes, right? So if you remember, till yesterday we were writing global class ABC we were writing, or public class ABC we were writing, public class ABC we were writing. So that means what we wrote classes till yesterday. Then there are interfaces, there are abstract classes. So when do I write class? It's not only specific to Apex, it's everywhere. So if you see Java, when to write class. If you see Apex, when to write class, interface, abstract class. If you come to ABAP, again same program, when to write class, when to write interface, when to write abstract class. If you come to .NET, same question. So the question is same in most of the technologies. Wherever object-oriented programming is there, so this question will be there. So let's understand when to use a class, when to use a interface, when to use a abstract class. Assume that I am implementing a project. Assume that I am implementing a project. In the project, assume that I have 10 methods. We have or we want 10 methods. And one method for connecting database. One method get the connections. Another method get the data. I'm just writing like this. Okay, another method put the data. Another method, let's say reports. Another method, let's say what do you want? Logging information. Another method to take care of logging information. Users creation. Another method, testing docs, something like that. Assume that we have 8 methods. Please understand the requirement. Let's say I am implementing a project for Dr. Reddy's lab. I am implementing a project for Dr. Reddy's lab, and on high level, this is what I want. That means in the Dr. Reddy's lab there will be a method which will connect to the database. There will be a method which get the connections. There will be one method, okay, get data, and writing the data. To get the reports, there will be a method, or to create the reports, there will be a method. To track the logging information, there will be a method. User creation, there will be a method. Something and all. Now, let's say I am starting the project. If I know the implementation for all this project, or let's say, assume that I am writing a class ABC. So, how many methods? Method 1. Okay, method 2. Method 1, method 2, method 3, and so on, so method 8. Okay, so now I started the project. Assume that right now which database is not finalized. So assume that right now which database is not finalized. That means I don't know the implementation for method 1. Suprit, hope you are recording.
Yes, sir. Yeah.
Okay. So assume that right now database is not decided. That means database, whether it is Oracle, whether it is something, whether it is a Sybase, not decided. That means I don't know the logic behind for this right now. But I know that there will be a method. I know there will be a method, but I don't know which logic I need to write here because database is not finalized. So therefore, do I know the implementation of this method right now? I don't know. Consider the first scenario. I know what is a database, I know how to get the connection, blah 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 blah. That means everything I know. That means implementation of this method I know. Implementation of this method I know. Implementation of this method I know. And so on, so on, so. Implementation of this method also I know. If you know implementation of all the methods, then you are good, you can go for the class. So therefore, class will have all implemented methods. Class will have all implemented methods. Now when to go for the other thing? Let's say again I am writing a class. Again I am writing a class and there is a M1 method, there is a M2 method, there is a M3 method, and so on so. And there is a M8 method. M8 method. Now see here. So right now assume that database connection is not decided. So which database we want to use, not decided. That means I don't know the implementation of this one. So database connections are not decided means we don't know how to connect, or we are not writing the connection to get the connections, or we did not write the logic to get the connections. But I know how to get the data. Okay, I know how to put the data, and that means I know implementation for some of the methods, but I don't know implementation for some of the methods. See, whatever I am putting in bracket, that means those are implemented methods. So I know logic to write for some of the methods, or I know some of the methods implementation, but I don't know the implementation for some of the methods right now. Later I will implement those. Let's take example of login. When you can do login, when you can implement login, once you complete all the steps. Before completing the steps, if you implement the login mechanism, that does not make meaning. So if you consider this scenario, let's say we know some methods implementation, but at this point of time we don't know some methods implementation. We know some methods implementation, but some methods implementation we don't know at this point of time. So that means this method is unimplemented method right now. This method is unimplemented method. Method 1 and 2 are unimplemented methods right now. Method 1 and 2 are unimplemented methods right now. And later I will implement it. So if any method is unimplemented, then you need to write abstract. If any method is unimplemented in the class, then you need to write abstract before the method. So abstract indicates that this method is not implemented right now and we will implement in future. We will implement in future. Okay, so therefore if any method in the class is abstract, then that class is abstract. Otherwise, if any method is abstract in the class, then that class is abstract class. So therefore, what is the conclusion? If you look at here, we know implementation for some of the methods and we don't know implementation for some of the methods. If you look at here, right now I don't know, I am not writing the implementation for method 1. If you are not writing the implementation for method 1 and you want to take care of it later, then make method 1 as abstract. Otherwise you need to implement it. You will be getting errors. If you are not writing abstract, then you will be getting errors. So make method 1 as abstract. If any method in the class is abstract, then your class is abstract. If any method is abstract in the class, then your class is abstract class. So therefore, class will have all implemented methods. Abstract class will have minimum one unimplemented method. Minimum one unimplemented method. And remember that you can also have all unimplemented methods here. But minimum is what? 1. So if you have minimum one unimplemented method, then that class is abstract class. Now let's take the interface. Interface ABC. Assume that I just know the method names and I don't want to implement right now anything. I don't want to implement right now anything. I'll implement it later. I'll implement it later. Depends upon the situations. Depends upon the situations. This concept is very much important because most of the cases these concepts will be there. Okay, so assume that I know the method names. Okay, there should be display method, there should be connect method, there should be login method, there should be creation method, something and all. But I am not implementing right now. I will implement it later. So if I am not implementing right now, then it is abstract. So if I am not implementing right now, then it is abstract. If I am not implementing right now, then it is abstract. If I am not implementing this one right now, then it is abstract. So therefore, if you look at here, this is a class, or assume that this is a class, and if you look at here, there is an unimplemented method. If minimum one in unimplemented method, then it is called abstract class. If minimum one abstract method, then it is an abstract class. But if you look at here, all unimplemented methods are there. If all unimplemented methods, still you can have abstract class. But to make a difference, you can also call this as, or you can also make this as interface. So interface says, or interface indicates that there are all unimplemented methods. So therefore, if you look at here, class will have all implemented methods. Abstract class will have implemented or unimplemented methods. Or abstract class will have implemented and unimplemented methods. Your interface will have all unimplemented methods. So now the question. So if all abstract methods are there, can I make this as abstract? Yes, still that is correct. But to make a difference that, okay, this particular class is having all abstract methods, better make that as interface. So therefore, the final conclusion is class will have all implemented methods. That means if you implement all the methods, then you can make that as a class. If you implement some methods and if you do not implement some methods, then it is abstract class. Abstract means like something. Interface is nothing but dummy. That means all unimplemented methods. Now, so in this project, how many methods are there? 8 methods are there. Now I'll ask the questions. So in this project, how many methods are there? N methods are there. N is equal to 8. So n is equal to 8. Now in case of class, how many implemented methods will be there? How many implemented methods will be there? Implemented methods, n. How many unimplemented methods? In case of class, 0. In case of abstract class, How many implemented methods? How many implemented methods? Answer, Suprit, Varsha. You can think now. Assume that there are n methods. So in abstract class case, how many possible implemented methods? How many possible unimplemented methods? So if you look at here, so here abstract class, even though you implement this, okay, assume that this you implemented. Assume that this also you implemented. Once you implement, you should not make that as an abstract. So you need to bring this to normal. So all methods are implemented, but still you can have abstract. But don't do that way, because all implemented and still if you have abstract you cannot create object. That's the problem. That's why. So but possibility is there. So therefore, what is the minimum implemented methods? Minimum implemented method 0. And the maximum, it can be n. How about unimplemented methods? If you look at here, all are implemented methods. So that means maximum are n. Unimplemented methods. Unimplemented methods means what? Abstract. So minimum can be unimplemented method. Maximum can be n and minimum can be 0. Maximum can be n, minimum can be 0, because there can be n number of implemented methods or there can be n number of unimplemented methods or mix. That's about abstract class. Now coming to the class. Now you can answer me, how many implemented class methods will be there? How many unimplemented methods will be there in case of interface? Implemented methods how many?
0.
Absolutely. Unimplemented?
N.
That's correct. So therefore, when to go for class? If we implement all the methods right away, then go for class. We want to implement some methods and we want to implement some methods later point of time, then go for abstract class. We don't want to implement any methods but just want to have a skeleton, then go for interfaces. Then go for interfaces. Okay? Now these are the if any methods are there, how many implemented, unimplemented methods, these are the comparisons. The next thing is that for class you can create the object, but abstract class you can't create. For interface also you cannot create. Because of the reason is, here unimplemented methods are there, here unimplemented methods are there. If unimplemented methods, then there is no meaning of creating the object. Creating the object means what? You are giving a physical form to that. So that's why you cannot create it. And one more thing is that yesterday we have seen. So whenever there is a class, minimum one constructor will be there. If we write the constructor, then compiler will not add. But if we are not writing the constructor, compiler will add the constructor. Yesterday I shown you. Do you remember? Yesterday I shown you. If we are not writing any constructor in the class, compiler is going to add a constructor called zero argument constructor. Okay? So therefore minimum one constructor will be there in case of the class. In case of abstract class it may or may not. But in case of interface there will be no constructors. So constructor won't be there. If you did not write, compiler also will not write. So no constructors. And if you want to, so classes can be extended. Classes can be extended. Abstract classes can be extended or implemented. Implements. Interfaces will be implemented only. So therefore, if you have a class, you can extend that class to some other class. If you have an abstract class, you can extend that abstract class or you can implement that abstract class. What does it mean? So I am extending this, whatever implemented methods are there, those will be available for me. I am implementing this, I am trying to implement the abstract methods. Abstract method means the methods which do not have implementation. So therefore, if I want to implement it, then you can use implements. If I want to use this, then you can use extend. But in case of interface, all are abstract methods. In case of interface, all are abstract methods. That's why implements will be there. Extends will be there. One interface extends another interface. Okay. These conclusions I will give you. Because of the reason is if I put this